The sum of two different numbers is 4. And the product, when we multiply these same two numbers, equals 13. So we could use variables, x and y. So let's rearrange the first equation for y. We're isolating for y, and we'll sub that into the second equation. So y would be 4 minus x as we move x to the other side. And then we'll sub that in for this y. So this second equation would become x times y, which we determined to be 4 minus x, equals 13. And you could probably predict we'll get some quadratic. So 4x minus x squared equals 13. We should rearrange this to put it into standard form. Minus x squared plus 4x minus 13 equals 0. And then you would determine if you could factor this. We actually can't factor it. We could flip the signs if we wanted by multiplying everything by -1. You don't have to. It might be a bit easier to multiply everything by -1 just to give us only one negative number. Then we'll plug it in. So we have a equals 1 from here, b equals -4, and c equals 13. So why don't you do that and see what you get. So I'll plug these in, I'll fast forward it. Okay, now how do we simplify this? We have a perfect square number under the root. Factor out the negative as an I. So we have a -1 times 6 squared. And when we have -1 underneath the root, we can pull that out as just I. And you remember when we have a square under the root, we can pull that out. So we would have 4 plus or minus 6i over 2. Now, because all of the terms are divisible by 2, we can actually reduce each one by 2. Even though we have I, just treat I like a variable x. Okay. So we'll divide all of them by 2, so we get 2 plus or minus 3i. And you can see that there would be two values of x, 2 plus 3i and 2 minus 3i. And this form that it's in is a complex number, where we have our number or constant, and then our imaginary number. Imaginary number always is written last.